Number 5, if sample is conducted, it's an SRS. I've got 663 registered voters. I want to see how they voted. Now we know the records show that the true P is 0.56. We're going to figure out that this is a normal distribution with this center and this standard deviation. So I know that my graph is going to be 0.56, 0.019, and the question here is what's the probability I get between 0.52 and 0.60. So what's the probability that my sample of 663 people is in that shaded region? So the first thing I'm going to do, now that I've drawn my picture, is I'm going to subtract the mean, divide by the standard deviation. This is the process known as standardizing it. We want to get pretty comfortable with doing this. Then I'll use my calculator to figure out what these numbers are. So it's 0.56 minus 0.52 minus 0.56 divided by 0.019. That's the left side. The right side then is 2.105 because it's symmetric in this case. Now we've got a couple of options. One option is to use my chart. So these numbers here will round to negative 2.1, or I could use 2.11. So for my chart, let's see if I can find that. Here's the table. 2.11. 2.11 is right there. 0174. 0174. And 2.11 is, of course, going to be over here. 2.11, it's 9826. It's this number right here, 9826. And then I can use my calculator to subtract those things, 0.9826 minus 0.0174, and I get this, 9652. I also allowed students to round it to negative 2.10, so their answer would be slightly different, or you might choose to use your calculator and say normal CDF, where the lower bound is negative 2.105 and the upper bound is 2.105, and I can paste that in there and I get this. And so I allowed any of those answers to work. You can see they're pretty close to the same thing either way. Part B then says, in fact, 72% said they had voted. You think they're being honest? If they were being honest, what's the probability that I could get a sample like that? So my graph, you'll recall, has a middle of 56 and a standard deviation of 0.019, and I want to know, what is this area? What's the probability that the number of voters is above 72%? So I standardized it. And then I use my calculator to go 0.72 minus 0.56 divided by 0.019, 8.42. Z is greater than or equal to 8.42. And I thought, wow, that's kind of a big Z value. And if this is a big Z value right here, then that means this area right here is kind of small. I said, well, let me look at the chart and see. So I pulled up my chart and I said, wow, that's not even close to being on the chart, which means the area to the right of it must be really tiny. So the question said, what is the probability? Well, it's really small. It's really close to zero. Some people also said that it was less than 0.0003 because they went with this, actually 0002, they went with that biggest number right there. and they subtracted it from 1, and so that's fine. You could do that. Say this is a 2 now. I'm okay with that. Really, the idea is that it's tiny, not 1. Few people forgot to subtract it from 1, but it's really close to 0. So based on that, do you think they answered truthfully? Well, what this means is if they answered truthfully, there's a near 0 chance that you could get a sample of, what did I say, 663 people in which 72% of them voted. It's nearly impossible. Since this is nearly impossible to get if P really does equal 0.56, I strongly, because it's so close to 0, suspect they aren't being truthful. And there's the idea on the last question.